Okay. So the idea is the following. You can say, I can decompose the motion into two parts. Okay. And you know that the axis of the disk is rotating about Z. صح? If you take the center of the disk here, I will call it C, this point. What is the velocity of C? Since omega, the plate is rotating about Z along this direction, C will do circular motion. Okay? And like this. So it will rotate. And since you have the angular velocity into this direction, the velocity from the right-hand rule, the velocity of C should be perpendicular to OC, okay, along positive I. So what is velocity of C as vector? It's equal in magnitude to omega P times the distance from O to C, which is 1. And omega P is equal to 1, يعني 1 times 1 equal 1 along I. So 1I equals to 1 along I. Okay? Now, if you want to write then the total velocity of point A, you can say that VA is due to two effects. It's due to the rotation of the axis about the Z-axis, which is due to velocity of point C. Plus, we can add to it the velocity of C relative to point A. Okay? Now, so
مش قادرة
this component who were the ones that we calculated here. Now, to calculate VC relative to A, how to do it? You say, relative to the point C, I have rotation about fixed axis. Yani, this is C, and this is A. A is here. And I have rotation in this direction. So we know that the velocity should be perpendicular to the radius, and it should be in this direction in order to rotate counterclockwise. And if I represent the velocity here, let me use another color. If I present the velocity here of A relative to C, it will be also along positive I.
يعني هلا دكتور لتوصل الاي بالسي انت عم تستعملي بس فكره التشابترز اللي قبل 2 دي مش 3
مظبوط
دي
100%
ايه اوكي
2D أكيد. يعني هون بهالطريقة قسمنا كأنك قسمتها ل 2D motion يلي هن الروتيشن of C about Z والروتيشن of A about Y axis. قسمت الاناليسز وساعتها when you do the summation you get the total velocity of A. يعني velocity of C relative to A is equal to omega S times the radius of the circle of the disk اللي هو distance between C and A, AC. And you know that omega S is 3. You know that AC is 0.25. So this will give you 0.75 along I. Okay. So in total, and this is directed along I, in total, what will be your VA using this analysis? It will be equal to 1I plus 0.75I. So 1I plus 0.75I equals to 1.75I. Okay? Which is the same result that we obtained using the other analysis. Any other question? You can do the same for acceleration also. Okay? But the other method is faster. You can directly from one equation, you can get the results. And you can verify that you got exactly the same result. Okay.
دكتور بس فيك تعلي لصور فوق.
ايه اكيد يلا.
Thank you.
Done?
Yes.
Okay. Okay. Now we'll discuss the case of general motion. So a translating coordinate system will be used to define relative motion. A rigid body can be subjected to general motion in 3D, for which the angular velocity is omega and the angular acceleration is alpha. Now, how we can determine the instantaneous axis of rotation? The instantaneous axis of rotation is, if you want, the axis for which all points will have a velocity of 0. Okay, and it's on this axis you have that omega total will be directed along this axis. So to find the instantaneous axis of rotation, you should try to find points of 0 velocity. And if you are able to calculate omega total, you can say that the instantaneous axis of rotation is along omega total. And the relations used to calculate to relate points are similar to the one we have used now in the previous problem. And if you can find, if you want, a point that is fixed on the instantaneous axis of rotation, and if you relate to it, you have that the velocity of point A is 0 because it is on the axis of rotation. So VB, so you can say that VB is simply VA, which is 0, plus omega vectorial AB. And for acceleration, the acceleration of B relative to A is alpha vectorial RB relative to A plus omega vectorial RB relative to A. So in case A is on the instantaneous axis of rotation, the velocity of A will be 0, but please not the acceleration. Pay attention for this, okay? So in case you found your instantaneous axis of rotation, all points on it will have إذا بدكم 0 velocity, okay? But the acceleration of these points مش ضروري تكون equal to 0, okay? إلا إذا يا شباب في particular case instantaneous axis of rotation، اوكي، في يكون البوينتس لإله اذا بدكم عندهم velocity بس بيكونوا عم يعملوا translation. كيف يعني؟ يعني مثلا اعتبروا عندي cylinder، اوكي، and this cylinder is rotating about this axis. إذا البوينت لهول الأكسس بهيدا الأكسس are moving along this direction، عندهم velocity like this، okay. But still the cylinder is rotating about this axis. يعني فينا نقول إنه ال points on the axis of rotation, instantaneous axis of rotation، فيكون عندهم velocity but they will not affect the rotation. okay. مهم إذا بدكم ال velocity component تبعهم ما يأثروا على rotation. يعني in general, in case you can find points of 0 velocity، أكيد بيكون هيدا instantaneous axis of rotation. بس كمان فيكون الاكسس البوينتس على الاكسس اوف روتيشن عندهم velocity بس بطريقه انه تكون is not affecting, if you want, the rotation of the body about the axis. Okay, هلا we'll discuss this in some examples. So we can say that if I consider translating axis, the relative motion will be as follow: VB equals VA plus omega vectorial AB, and AB equals AA plus alpha vectorial AB plus omega vectorial RB relative to A. Okay? And for general plane motion, alpha and omega will always be parallel or perpendicular to the plane of motion.
الاوميجا هون غير الاوميجا تبع اللي حطيتيهم الفورمولاز تبع instantaneous axis، يعني هديك الاوميجا around الانستنتينيوس axis اللي قبل.
ما هي الاوميجا هي ذاتها، ما في اوميجا اراوند الانستنتينيوس وغير الانستنتينيوس. الاوميجا توتال هي ذاتها بكل الاحوال. بس انت اذا لقيت الانستنتينيوس اكسس اوف روتيشن، تنقول انه لقيته وقلت انه الفيلوسيتيز على 0، اوكي، يعني انت هون بتحط زيرو فبتطلع في بي ايكوالز اوميجا فيكتوريال ار بي ريلاتيف تو اي، بس الاوميجا ما تغيرت. يعني الاوميجا
على طول
هي
هي
فور ذا ريجيد
الريزلتنت.
بودي ما بتتغير اذا انت عم تشتغل على اذا الايت بوينت على الاكسس اوف روتيشن اور نوت. انت عاده اذا
اوكي.
فهمت علي كيف؟
يس، هي على طول الريزلتنت، يعني الاوميجا ما خص انه وين، بس
ما
انه هون
خص
المسائل
وين،
قصدي.
مزبوط، ما
ايه.
خص وين. exactly. اوكي.
دكتور،
نعم.
مثل قبل شوي طلعت معنا الأوميجا توتال 3J minus K، هيدي هي direction تبع ال instantaneous axis of rotation.
yes yes exactly yes.
أوكي.
Okay. Let us do a problem to practice on this. One end of the rigid bar CD shown slides along the horizontal member AB, and the other end slides along the vertical member EF. If the collar at C is moving towards B at a speed of 3 meters per second, determine the velocity of the collar at D and the angular velocity of the bar at the instant shown. هتشوفوا انه في كتير similarity between what we learned in this chapter and what we learned in chapter 16. So what do we have here? We know the velocity of one point completely. For point C, vector VC is known. It's equal to 3J. Okay? And you have that for point D is moving along EF. So you are sure that the velocity of D is along Z. But you don't know what is the magnitude. يعني VD vector, you can write it as you can do analysis انه if C will move like this, D will move downward. Okay, so you can write minus VD J K, sorry. Okay, and since you have general plane motion here and it's a 3D problem, okay, you can say that omega vector omega is equal to omega x in I plus omega y in j plus omega z in k. Okay, and you want to determine what is VD, the velocity of the collar, and what is the angular velocity of the bar at this instant. So you want to determine omega x, omega y, and omega z. Okay.
دكتور شو هي اللي عندها angular velocity ال AB؟
السي دي الرود سي دي.
اوكي.
رود سي دي. Okay. Okay. So first, bar CD is subjected to general plane motion. So we can relate the velocities of point C and D by VD equal to VC plus omega vectorial CD. And the fixed and translating frames of reference are assumed to be coincident. يعني نحن what we are doing here, we are considering إنه small xyz and big xyz to be coincident at this instant. In general, small x, small y, small z will be attached, if you want, it can be attached to the to the translating. يعني point C is translating. You can attach small x, small y, small z to it. Okay, and study the relation between velocities of point C and D. يعني if you remember, we did this in chapter 16. We considered a frame fixed to C, and we said how to determine the velocity of D with respect to this frame. So we need to consider first the velocity of the origin of the frame, which is point C, plus the velocity of D relative to C. Okay, and when we do this, we can say that when we divided, يعني كأنه إذا بدكم, we divided the motion into a translation plus rotation. Translation effect is considered through the translating frame attached to C, and the rotating effect is by considering relative to this frame the rotation of point D relative to C. Okay, and we know that omega total, when we consider the effect just of rotation, omega total is perpendicular to the, at each instant, to the plane of motion. Yani at this position, this is line CD is in the plane of motion. So vector omega total is perpendicular to CD at this instant. Okay, so we divided the expression into translation effect plus rotation effect. And when we want to do the calculation, we say that VD is minus VDK, VC is 3J, and now we have that omega is decomposed into the component of rotation. Since we don't know the direction of rotation, it's decomposed into three components, x, so omega xi plus omega yj plus omega zk. So we have four unknowns, okay? We have here, the four unknowns are VD, omega x, omega y, omega z. We know that a vectorial relation in 3D will give us only three equations. So we need an additional equation to solve for our four unknowns. دي اللي هن VD, omega x, omega y, and omega z, okay? To be able to close the system of unknowns, we should use that omega total is perpendicular to CD. So this will give us a fourth equation. Let us discuss how to do it, okay? So first we will write VD, which is minus VDK, is equal to VC, which is 3J, plus, we said that we need to do now omega vectorial. So now we need to do omega vectorial CD. And according to the figure, CD vector has known components. And if you look at this figure, you have the coordinates of point D. From coordinates of point D, you can find the coordinates of vector CD. And if we look at the figure for point C, the coordinates of point C, C is on y-axis, yani 0, 1, 0. Now for point D, for point D, I have along x, it's a +1. Along y, it's 1 plus 2 equal to 3. And along z, it's minus 0.5. Okay, so now I can just do for vector CD x of D minus x of C. So I have 1i plus 3 minus 1 along J plus minus 0.5 along K. Okay, so I can do the expansion directly. I can expand directly, or if you want, I can use the matrix form I, J, K, omega x, omega y, omega z, and here's the components of CD vector 1, 2, minus 0.5. So I just have to put plus, minus, plus. So I have plus I times minus 0.5 omega y minus 2 omega z minus j times minus 0.5 omega x minus omega z and minus omega x times minus 0.5 and finally plus k times 2 omega x minus omega y. So this is my vectorial relation. But since it's a vectorial relation in 3D, it will give me, so comparison along I will give me equation 1. Comparison along J will give me equation 2. And comparison along K will give me the third equation. But here I have 4 unknowns, okay? So perpendicularity is guaranteed provided the dot product omega and RD relative to C is 0. So we said omega total is perpendicular to the rod to CD, okay? So I have that since omega total is perpendicular to CD, since as we said we decomposed motion into translation of C plus rotation of the rod about point C. So omega total will be perpendicular to DC. So we can say that this information will give us additional equation. So additional equation is that omega dot RDC is equal to 0 because whenever you have two vectors that are perpendicular, their dot product will be equal to 0. So I can write that omega xi plus omega yj plus omega zk dot product vector CD is equal to vector CD equal to 0. So if I do the dot product, I multiply x component of the first vector by x component of the second plus y component of the first times y component of the second plus z component of the first times z component of the second equal to 0. So now I obtain a fourth equation to close my system of unknowns. So I have now 4 equations, 4 unknowns I can solve for my variables. Okay?
هون لانه الاوميجا بيربنديكولر على الفريم اوف موشن مشان
Yes.
هيك
لأنه
في
نحن
perpendicularity
قسمنا
بين.
نحن بالجنرال بلين موشن تتذكروا شو كنا نعمل؟ كنا نقسم الموشن into translation plus rotation. يعني كنا ناخد small x small y small z يكون عم يعمل translation with one point of the rod. انت if you take this frame translating اجباري ساعتها اوكي اجباري ساعتها when you are standing on this frame what D is doing what relative to C ما انت الديستنس بيناتهم fixed صح؟ So distance between C
Yes.
and D is fixed يعني D is doing rotation about C. Okay?
Yes.
So
Okay.
that's why بما انه انت you decoupled the translation and rotation. So now you are looking at the rotational effect of D about C. So at this instant, this omega total is perpendicular to CD. Okay?
انا اخذتها بطريقه لانه السي دي منهم بذات الفريم، بس انا اخذتها بطريقه انه سي دي هن بفريم فهنا عم يبرموا الاوميجا حتكون بيربنديكولار على هيدا الفريم.
صحيح. هتكون perpendicular على السي دي على الاوبجكت. يعني انت عادة اوميجا each instant is perpendicular to the plane of motion. Okay?
Yes, that's why الدوت برودكت بيناتهم equal 0.
Yes. اوكي.
دايما
دكتور هل
بتكون
إذا أنت أخذت
perpendicular.
الفريم على الستيل
انت مش قصة دايما انت هون رفيق كيف اخذت لانه كيف اخذت الفريم small x small y small z اخذته translating مع البوينت سي يعني انت كانه you decoupled يعني yes يعني when you write this relation you decoupled ال translation والrotational effect. Okay? So الأوميجا توتال هي perpendicular على the plane of motion the plane of rotation بهاللحظة و CD is in this plane هيدا اللاين is in this plane. اوكي يعني انت اذا بتلحق البلين اوف موشن بكل لحظه
مم.
سي دي حتكون
طب
بقلبها.
إذا ما كنا أخذين الأكس واي
لا اجبار الاكس واي زد يكونوا ترانسليتنج هون.
أوكي لو إذا ما كنا أخذين الأكس واي
نعم
اوكي
ما انت تتكتب هيدي الريليشن شو
اوكي
الكونديشن تقدر تكتبها هيك. اوكي، الكونديشن انه تكون اخذ الفريم at C translating، لانه you decouple the translation
صح
of point C and rotation of point D relative to C. تتذكروا بتشابتر 16 وقت
مم.
شرحنا هاي الفورمولا مش قلنا نحن كيف بنقسم الموشن؟ بنقول اذا بناخذ translating frame at C وبوقف ساعتها بوقف على C، شو بإشارة دي عم يعمل؟ rotation، لأنه الديستنس بين C و D is fixed. اوكي،
يس
يعني
اوكي
according to this relation
حلو
كأنه you decouple the translation effect من الروتيشن effect.
ايه اوكي ميرسي.
اوكي،
دكتور هنا هون حاطين انه الفريم اخذوه coinciding مع العادي، يعني حاطينه at point A، عم بيأثر شيء اذا حطيناه at A
ما
او على
بيأثر،
C؟
لا ما بيأثر شيء إذا حطينا على C، ما بيأثر شيء. اوكي، يعني حتى انت فيك تحطي
اوكي
هون الفريم، شو بيتغير؟ ما بيتغير شيء. اذا حطيتي سمول اكس سمول واي سمول زد هير حيتغير شيء؟ لا. اوكي،
اوكي
اوكي. هلا the most complex scenario، هلا اذا بدكم we can keep this section to next time. اوكي، so next
Yes.
time لاحظتوا انه we are doing the same if you want steps of chapter 16 بس انه it's more advanced because omega is in 3D. يعني مثل ما اشتغلنا ب translating axis و ب rotating axis in chapter 16 also we'll work here with translating and rotating axis in this chapter. Okay, so we'll continue next time. Bye.
Okay.
دكتور
Yes.
بالاكزامبل فوق ليش الاوميجا it's rotating in this direction؟ انا بس عم حط ايدي عم تطلع معي بالقلب.
وين؟ هيدا أو اللي قبله؟ Which one you mean, Michelle?
هذا الاكسرسايز
إيه.
this
أنت
one.
look هون ماشي، هون you assume a direction and from the solution you will get the component of omega, omega x, omega y, omega z.
اوكي بس مثلا مش بناخدها حسب في سي عم بتروح لهونيك، سو باي رايت هاند رول
هلا
بتكون
فيك تعملي انت
rotating
تجربي you can try to determine what will be the direction. okay, by doing the right hand rule. بس ما هون انت عندك 3 components، يعني مش انه عندك positive k و negative k، يعني بدك تقعدي تعملي analysis اذا omega x positive او negative omega y omega z. so يعني no need to do this effort. you can just assume انه 3 components omega x omega y omega z, and then when you solve if they are positive يعني هن along positive direction, if they are negative يعني هن along the negative one.
اوكي دكتور ميرسي.
Welcome.
هون فينا نطلع نحن instantaneous axis of rotation، ما هيك؟
في هلا ال instantaneous axis of rotation بال 3D is much more challenging. اوكي، يعني انت في specific cases هلا نحن بس نحل problem دغري بتصيروا تقشعوها. عادة بس نكون
طب
عندنا rolling without slipping، يعني بيكون في point of zero velocity. واذا عندك rotation about two axis يعني فيك تعرف انه في point fixed، ساعتها فيك تلاقي 2 points، بس تلاقي 2 points مثلا velocity لهم زيرو بتكون لقيت instantaneous axis of rotation. اوكي،
بوصلهم ببعض بكون لقيته. اوكي
إيه. بس اوقات it's challenging to find it، يعني هون ما في شيء obvious انه شو هن البوينتس اللي عندهم zero velocity. اوكي،
اوكي دي
ما له
مهمة
كثير
كثير.
نوع. اوكي، any other question on this? Okay, yellow, we continue next time. Bye bye.
Thank you, bye.
Welcome.
Thank you,
Okay.
doctor.
Thank you, Doctor.
Welcome.